Hello math learners! For this video, we will be learning about compound interest, part 1. Consider an investment whose time frame is divided into equal intervals. If an interest is computed after an interval and is being added to the principal and thereafter earns an interest, then the difference between the original principal and the total amount after the whole time frame is called compound interest. The compound amount or the accumulated value of the principal is the sum of the principal and the compound interest. In this situation, we see that the interest is being converted into a principal, and thus we use the phrase interest is compounded or interest is converted. Here is the formula in solving for the compound interest. In solving for the compound interest, we have this formula: F equals P times the quantity of 1 plus I raised to the power of n, where F stands for the compound amount or accumulated value of P at the end of the term. P stands for the present value or the original principal amount. I stands for the interest rate per period, and n stands for the total number of conversion periods. Now, how do we solve for the value of I? We follow this formula. We have I is equal to J divided by M, where J stands for the interest rate per year, and M stands for the number of conversions per year. By the way, how do we determine the number of conversions? This can be determined by the following time frames. Example, when you say annually, that means you are going to pay one time only per year. If you say semi-annually or biannually, that means you're going to pay twice in a year. When you say quarterly, that means you're going to pay 4 times within the year. And when you say monthly, of course, you are going to pay 12 times in 1 year. And then finally, we have this formula. N is equal to T times M, where N is actually the total number of conversion periods, which can be determined by multiplying the values of T or the term or time. And then we have M, which is the number of conversions per year. In the context of compound interest, the interest rate per annum or per year is called the nominal rate of interest. Thus, when a given nominal rate is said to be compounded quarterly, that means in a given year, there will be 4 conversions. Similarly, when we say compounded monthly, the conversions are made every month. Therefore, in a given year, there will be 12 conversions. For us to understand better the concept of compound interest, here are some examples. Example number 1. If 2,500 pesos is invested at 13% compounded quarterly for 12 years, find the compound amount and interest. For this problem, we are asked to identify the compound amount, meaning the future value, and the interest. Now, let's solve. Here are the given for example number 1. For our principal amount, we have 2,500 pesos, and for the J, which is the nominal rate, we have 13% or 0.13. We also have the term, which is equal to 12 years, and the number of conversions, which is 4, since it is said to be quarterly. Now, solving for the value of n, we get T times M. T is 12 and M is 4, therefore the product is equal to 48. Then getting the value of I, we divide J by M, and we have 0.13 divided by 4. Then the value of I is 0.032 and 5. Now, having all of this given, we can now solve for the future value. We have this formula. F equals P times the quantity of 1 plus I raised to the power of n, and we substitute the values for this variable. We have 2,500 pesos times the quantity of 1 plus our I, which is 0.0325 raised to the power of 48, which is our n. Then we just copy 2,500 pesos, and then we add 1 and 0.0325, then we get 1.0325. Now we're going to get the value of this number raised to the power of 48. Then we get 4.6421898. So for this example, I had this in 7 decimal places, but you can actually have this one shorter. But for us to be able to have a higher chances of getting the exact answer, then I had it on 7 decimal places. Now, the next thing to do so that we can derive the final answer, we just multiply 2,500 pesos by 4.6421898. You can actually use your calculator. Then we get 11,605 pesos and 50 cents. This is already the answer after rounding off to the nearest hundredths, or we rounded it off so that the final answer can only have 2 decimal places. Then we have example number 2. If 3,700 pesos is invested at 12% compounded semi-annually for 5 years, find the compound amount and interest. For this example, we are going to solve again for the compound amount, or the future value, or F, and the interest. Take note that the number of conversions will be based on this statement, which is semi-annually. Now, for the solution for example number 2, we have the following given. Our principal amount is 3,700 pesos. Our J, or the nominal rate, is 12% converted to 0.12. Our term is 5, and our M is equal to 2 since it is said to be semi-annually. Now, getting the value of N, we multiply the values of T and M. We have T is 5 and M is 2, so we get the product of 10. And then multiplying, getting the value of I, we divide J and M. So we have J is 0.12 and M is 2. So getting the quotient of 0.12 and 2, we get 0.06. Now, having all of this given data, we can now solve for the compound amount, or the future value. Then, following the same formula, we substitute the values. Then we have P is 3,700 pesos times the quantity of 1 plus our I is 0.06 raised to the power of N, which is 10. Then we are going to add 1 and 0.06. Then we get 1.06 raised to the power of 10. Now, getting the value of 1.06 raised to the power of 10, we get 1.790847. Again, I rounded off the value for this one to 7 decimal places. Then multiplying this value to 3,700 pesos, we get the product of 6,626 pesos and 14 cents. The final answer, I rounded it off to 2 decimal places. So after getting the product, you'll just have to round it off to 2 decimal places so that it can be in its right or correct peso form, which is 2 decimal places. Then, let's have example number 3. Find the present value of 2,850 pesos due in 5 years if the money is worth 10% compounded quarterly. So for this problem, we have the principal amount, the term, and the nominal rate, which will be computed with the conversion of 4 because it is quarterly. Now, we are going to look for the value of the present value. Here's the solution for example number 3. We have the following given. Our F, or the future value, is 2,850 pesos. Our J, or the nominal rate, is 10% converted to 0.10. The term is 5 years. We have 5. And then our M is equal to 4 since it is quarterly. Then, solving for the values of N and I, we have T, which is 5, times M, which is 4, is equal to 20. Therefore, our N is equal to 20. Getting the value of I, we have J divided by M, which is 0.10 divided by 4. Then we have our I is 0.025. Having all of this data, we can now solve for the present value. Here's the formula for solving the present value. We have P is equal to the future value, or F, divided by the quantity of 1 plus I raised to the power of N. Substituting the values, we have F is 2,850 pesos divided by the quantity of 1 plus our I is 0.025 raised to the power of N, which is 20. Now, adding the values of 1 and 0.025, we get 1.025. Then, to proceed to the next step, we will just have to get the value of this one raised to the power of 20. And that is 1.6386. Okay. And then afterwards, we divide 2,850 pesos by this one. Then, our quotient is 1,739 pesos and 29 cents. I rounded it off to 2 decimal places so that it will follow the trend for our peso. Here's another example. How much must be invested today in a savings account to realize 9,000 pesos in 4 years if money earns at the rate of 4% compounded quarterly? Now, let's analyze the given data. We have the nominal rate, which is 4%, and it is to be compounded quarterly. Since it is said to be quarterly, therefore, our M will be equal to 4. Okay, then the term is 4 years, and the money is to be realized at 9,000 pesos. Therefore, this is the future value. Now, the question is, how much must be invested today? Therefore, what is being asked in the problem is the present value to be invested. Now, let us look at the solution for example number 4. We have the following data. Our F is 9,000 pesos. Our J is 4% or 0.04 in decimal. Our term is 4 and our M is also 4. Now, solving for the values of N and I, we have the following. Our N is equal to T, which is 4, times M, which is also 4. We get 16. And for the I, we have J divided by M, or 0.04 divided by 4 is equal to 0.01. Now, with this given data, we are going to solve. Since we are solving for the present value, then we have this formula. P equals F divided by the quantity of 1 plus N raised to the power of N. Substituting the values, our F is 9,000 divided by 1 plus our I, which is 0.01, raised to the power of 16. What we're going to do next is we are going to add 1 and 0.01. Then we have 1.01 raised to the power of 16. Solving for the value of this one, you will get 1.1726. Then finally, we divide 9,000 pesos by 1.1726 and we derive the answer, which is 7,675 pesos and 25 cents. Therefore, the amount that must be invested today is this one. Here is example 5. What rate compounded annually will double any amount principal if it is invested in 6 years? For this problem, we are asked what is the nominal rate. And the problem is we only have the t as our given. Now, we are going to identify the rate if the principal will be doubled after 6 years. Now, how are we going to do that? We are going to let x be the amount to be invested. Then, we are going to find the value of j. Here's the solution for example number 5. We already know that the term for the given problem is 6 years. To be compounded annually, therefore, our m is equal to 1. Now, solving for the value of n, we will multiply the values of t and m, which are 6 and 1. Therefore, we get the product of 6. Now, we are going to solve for the future value. We have this formula, f equals p times the quantity of 1 plus I raised to the power of n. Now, what would be the value of our f? We know already that our initial amount to be invested is set as the variable x. And after 6 years, this value will become doubled. Hence, the value of f would be 2x equals the p, which is set as x, times the quantity of 1 plus j over 1. Take note that I is equal to j divided by m. And since we do not know the value of j yet and we are looking for this value, this variable will remain as j raised to the power of 6, which is the value of our n. Now, how are we going to simplify this one? All we have to do is just to divide both sides by x so that we can simplify this one. Then, we have this. 2x divided by x is equal to 2. And then we cancel x right here since x divided by x is 1. So it becomes 2 equals the quantity of 1 plus j, since j divided by 1 is j, raised to the power of 6. Then, simplifying this one further, okay, we got the 6th root of 2 equals 1 plus j. How did we derive this? Since in this part of the equation, we have this quantity raised to the power of 6, in order to eliminate this one, for this one, so that our variable j will be free, we are going to solve for the 6th root as well of this part of the equation. Hence, 2 with its symbol for the 6th root equals 1 plus j. Since getting the 6th root of this one, we will just cancel 6. Okay, let me illustrate. So, we solve for the 6th root. Okay, this will be 6 right here. I just assume. And then we're also going to solve for the 6th root. And then, this is 6 right here. We will just have to cancel 6. That's why what's left are 6th root of 2 equals 1 plus j. And then, so that we can get the value of j, all we have to do is just to subtract both sides with subtract both sides with 1, or move this value to the right side and change its sign. Then we have this one, j equals the 6th root of 2 minus 1. Since if you move the value of you move positive 1 to the other side, it becomes negative 1. So we have here j is equal to the 6th root of 2 minus 1. Now, using your calculator, you solve for the value of this one. We have j, which is equal to 1.1225 minus 1. We will just going to subtract this one, then we will get 0.1225. Then we're going to convert this one into its percent form. then we get 12.25%. So therefore, this is now the nominal rate for our problem in example number 5. Let's have another example with this example number 6. What nominal rate converted semi-annually will make 20,000 pesos amount to 50,000 pesos in 8.5 years? Take note that we are asked what will be the nominal rate given that our present value is 20,000 pesos, which will become 50,000 pesos after 8.5 years. Take note that 20,000 pesos will grow semi-annually. It's just that we do not know the nominal rate yet, and that is what we're going to solve. Now, given that the term of this given problem is 8.5 years and m is 2 because it will grow semi-annually, so compounded semi-annually. Therefore, the conversions is equal to 2 because it is going to grow twice in 1 year. So to get the value of n, we will just have to multiply t and m. Therefore, 8.5 times 2, it is equal to 17. Now, with all of these things already given, we are going to find the value of j. Substituting the values previously given, we have the formula f is equal to p times the quantity of 1 plus I raised to the power of n. For this example, we are using the formula for the future value, although we are looking for the value of j. Now, substituting the values, we have our f is 50,000 pesos equals our p, which is 20,000 pesos, times the quantity of 1 plus the I can be derived by dividing j and m. Take note that the money will grow semi-annually. Therefore, our m is equal to 2. And then this quantity will be raised to the power of 17. Now, to simplify this, all you have to do is just to divide 50,000 pesos and 20,000 pesos by this number, the smaller number, which is 20,000 pesos. Therefore, we have this. 50,000 divided by 20,000 is equal to 2.5 equals the quantity of 1 plus j over 2 raised to the power of 17. You might be wondering, why is it that there's no number here anymore? That's because after dividing both sides by 20,000 pesos, we have here 2.5, and then right here, 20,000 divided by 20,000 is 1. And you can actually have 1 unwritten anymore. That's why this is what's left. Now, for us to be able to get the value of j, here's what we're going to do next. Okay? Just like what we did earlier, we are going to eliminate the power or the exponent 17 in this quantity by getting the 17th root of the both sides of the equation. So we do it this way. Okay? So getting the 17th root of 2.5, and then on the other side as well, we are going to get the 17th root. Now, we are not going to do anything at all with this side, but for this side, we're going to eliminate 17. Okay, so this will become cancelled and cancelled, eliminated. Therefore, we have here the 17th root of 2.5 is equal to 1 plus j over 2. Now, we have to make sure that we are going to get j alone on one side of the equation so that it will be easy for us to solve. But then, there's still a denominator which is 2. Now, we are going to eliminate this 2, and we can do that by this one. We are going to multiply both sides of the equation by, of course, the number 2. So, We do it this way. Okay. Multiplying both sides of the equation by 2, we have here 2 times the 17th root of 2.5. This is the answer. 2 times the 17th root of 2.5 equals, since we have here 2 multiplied to this side of the equation which has 2 terms, then we have 2 times 1 is 2 plus 2 times g over 2. All we have to do is just to cancel 2 and 2. That's why we have only j left. Now, for us to be able to have j alone on one side of the equation, all we have to do is just to move positive 2 to the other side of the equation and change its sign. Then we get this one. We have j is equal to, you will just have to copy 2 times the 17th root of 2.5 minus 2. Why did it become negative 2? It's because it's positive right here, so when we move it to the other side of the equation, it becomes negative. Now, solving for the value of this one, all we have to do is just to use our calculator by getting the 17th root of 2.5 and then multiply it by 2. So, solving for the value of this one and multiplying it by 2, we will get 2.1108. And then minus 2, we get 0.1108. And then, converting this decimal value to its percent form, we get 11.08%. Therefore, for this problem, our nominal rate is equal to 11.08%. For us to understand better, let us have another example. When will 30,000 pesos earn interest of 45,000 pesos if it is invested at the rate of 7.5% compounded annually? Based on the given problem, we have the following data. Our future value, or F, is 45,000 pesos. Our P, or the present value, is 30,000 pesos. Now, our P, which is 30,000 pesos, will be compounded annually with the nominal rate of 7.5% or 0.075. And our M is equal to 1, since it is said to be compounded annually. Again, when it is said to be annually, then the conversion is only 1. Now, given the following data, we are going to solve for the value of t. We solve example number 7 using the given formula. We have f equals p times the quantity of 1 plus I raised to the power of n. Now we substitute the given values. We have f is 45,000 equals p, which is 30,000, times the quantity of 1 plus 0.075 is the value of j divided by 1, which is the value of m. We are using these values because I is equal to j divided by m. And then we have here this quantity raised to the power of n. N is an unknown value because we do not know also the term yet. Now, to simplify this equation, all you have to do is just to divide 45,000 and 30,000 by this one. So we have 45,000 divided by 30,000 is 1.5. 30,000 divided by 30,000 is 1. And we don't have to write 1 anymore. So we proceed with the quantity 1 plus 0.075 raised to the power of n. Then we add these values inside the parentheses. We have 1.5 equals 1.075 raised to the power of n. We can actually simplify this one by having the base for each of these sides of the equation equal. so that we can eliminate the bases. But then in this case, we cannot do so because there is no such number that is that we can use as base common between 1.5 and 1.075. Therefore, the best way to solve these types of problem is by using the laws of logarithm. Now, we have here setting the logarithm of 1.5 equal to n logarithm of 1.075. We have here, we divide both sides of the equation by logarithm of 1.075 so that we have n left. Then we have, okay, take a look. We have here n, and then we divide both sides of the equation by this one. That's why we have logarithm of 1.5 divided by logarithm of 1.075. Then, using the calculators, you find the value of this one. So we have logarithm of 1.5 is 0.176091 divided by the logarithm of 1.075 is 0.031408. Now, after getting the values of these two logarithms, you divide, and then you will get n, which is equal to 5.6065. Now, since we already know the value of n, we can now solve for the value of t, which is the term of the loan. Now, using the formula t, which is equal to n divided by m, we substitute the values. We have n is 5.6065, which is right here, divided by m, which is 1. Then we divide these values. We have 5.6065 divided by 1. It is equal to 5.6065. Therefore, for this problem, the term is equal to 5.6065. Now we are down to our last example. When will a principal double itself if the interest rate is 14% compounded quarterly? The problem may look simple, but it is not as easy as it seems. Now, we have the following given data. Our f is equal to 2p. Why is that so? It's because it is said that the principal will double itself. Therefore, our f, or the future value, will have our p times 2 because it is the principal doubled. Okay? Then we have our j, which is the nominal rate of 14% or 0.14. Then we have our m, which is equal to 4. Since when you say quarterly, that means it will be paid or it will grow 4 times in 1 year. Now, with the following data given, we will be looking for the value of our t. Solving for example number 8, we have f equals p times the quantity of 1 plus I raised to the power of n. Then we substitute the values. We have f equals 2p equals p, we just copied this one, times the quantity of 1 plus 0.14 over 4. We have these values because I is equal to j divided by m. Our j is 0.14 and our m is 4. Then, this quantity is raised to the power of n. Now, to simplify this one, we are going to divide 2p and p by this one. We have 2p divided by p equals 2. Then we have equal sign. P divided by p is 1. We don't have to write 1 anymore, so we proceeded with this one. We have the quantity of 1 plus 0.14 divided by 4 is 0.035 raised to the power of n. Then we add 1 and 0.035, then we get 2 equals 1.035 raised to the power of n. Again, we cannot express this 2 in its exponential form having the same base because of the decimal places right here. So we are going to use the logarithms. Now, setting the logarithms of these numbers, we have logarithm of 2 equals n logarithm of 1.035. Now, we are going to solve for the value of n by dividing both sides of the equation by the logarithm of 1.035. That's why we have here n equals logarithm of 2 divided by logarithm of 1.035. Using your calculator, you solve for the values of these two. We have logarithm of 2 is equal to 0.301030. For this one, I rounded off the value into 6 decimal places. And then logarithm of 1.035 is equal to 0.014940. Again, this was rounded off to its nearest 6 decimal places. Then we divide these values right here. We get 20.1493 for our value of n. Now, since we already know the value of our n, then it's time for us to solve for the value of t. Using the formula of t equals n divided by m, we substitute the values. We have n is 20.1493 divided by m, which is equal to 4, since this is compounded quarterly. Then we divide 20.1493 divided by 4, we have 5.0373. Therefore, for this example, the term is 5.0373. Oops, we're not yet done. Check out the second part of this video about the compound interest. See ya!